This video is sponsored by SMW Autoblock. When it comes to innovation, most people think that it happens inside a factory. But the truth is, factories can't always afford to experiment. They can't always afford failure. So to test new ideas without the risks hanging over your head, new ideas have to be tested somewhere built for creativity and innovation for the next generation. Today, we're at one of those places, Clemson University's International Center for Automotive Research. So join us on this episode of Road Trippin' with Steve as we take a peek behind the curtain at some really cool innovation and some really sick cars. Hey guys, Matt, how's it going?
Hey,
Drew,
Clemson University. How's it going?
Good to meet you guys.
So this is the Clemson University International Center for Automotive Research, where we do everything for vehicles, research and development, as well as teach the next generation of automotive engineers.
That is so cool, man. As a gearhead myself, this is going to be quite the experience. So where should we start?
We can start right here in the lobby with one of our deep orange vehicles. So this is one of the showpieces for our engineering students. They all go through and develop and build their own prototype vehicles, where they go all the way from start to finish of understanding the customer, who they're designing for, what they want, and what they really are going to expect out of future vehicles. And we're not talking right now, we're looking 5, 10, 15 years into the future, as well as they look at how can we actually build and assemble and design that vehicle. So they work with the professional design team. Engineers are great, we love them, but we love designers as well, and they have to also learn how to talk and work with the design teams. And then we actually go out and design the vehicle over about the first year, and the second year we actually build it. So they get a lot of hands-on experience, really good time of learning the different engineering practices, how to manufacture things. That's a big one for this, as well as what happens when we need to pivot and we need to make changes and make it work, even though some of the materials and systems don't exist yet.
Don't get me wrong. Despite my editor making fun of me, I am a gearhead. Everything about cars and engines makes sense to me. I even got to visit an assembly line in Detroit where they make cars. But the idea of designing systems and materials that don't even exist yet, as Matt just said, that's where I start realizing I might be out of my depth. Because it's one thing to imagine the future, it's another thing to entirely build it, to test it, and make sure it actually works. And based on what I saw when I flew to the airport near Clemson, these students were doing some really cool stuff. And I got to talk to one of those students, Drew, who was working on their project called Deep Orange. So what do we have here, Drew? Look at these cool cars, man.
These are two of our Deep Orange builds. So on the left here, we have Deep Orange 11.
Can I go in?
On the right, absolutely. We've got Deep Orange 10 over here. Feel free to make yourself at home. So this was a partnership vehicle that we built with ExxonMobil. So two of the primary themes with this vehicle were sustainability and accessibility. So a lot of the materials used in this vehicle are either recyclable or able to be repurposed. So as you can see here, we've got a wheelchair ramp. So people who are in a wheelchair, they can use this vehicle as well. It's a feature that you don't really get in a lot of autonomous vehicles. And yeah, I'm sure as you've noticed by now, this vehicle has 0 steering wheel, 0 pedals, anything like that.
Not even a screen. I don't even get a dashboard in here?
Nothing, yeah. So there's one small readout up there, and that'll tell you information like where you're going and the destination. But yeah, a lot of this vehicle is controlled by like voice control and methods like that.
Wow.
But yeah.
I see a lot of carbon. I see a lot of, is this carbon too, or is this like glass-filled nylon?
So those are, I'm pretty sure those are glass-filled nylon.
Fiber reinforced plastic?
Yes.
This is sick.
We actually, so the carbon that you were talking about, the frame of the vehicle here, so a lot of the vehicle frames are usually built out of steel or aluminum. This is a fully carbon fiber frame that we built.
Okay.
And then all of the nodes.
But the joints. Yeah. I also noticed the joints are, this is 3D printed and it's branded by AddUp, which is a collaboration company between Fives and Michelin, right?
Yes. Yep.
That's awesome.
So we use them. We use their
3D printed.
We use their metal 3D printer to create these nodes
titanium?
right here. I believe it is.
Okay.
I'm not
man.
quite sure on the material, but yes, they are all custom designed nodes to hold all the carbon fiber together.
This is sick.
That helps with the eco-friendliness of the vehicle because it's so lightweight because of the carbon fiber frame that it's able to go further on a full charge.
And I like that the seats can fold up so you can actually fit the wheelchair in
Absolutely,
here. That's
yeah.
really...
Or if you just need more storage.
These autonomous cars they had built were really impressive, and while I enjoyed looking at their different builds, I was excited to get a look behind the scenes of how they were developing and testing these vehicles and all the technology that went into them. But before we got to that, I just have to show off this really sick build.
So this vehicle over here is currently not on its tracks. So the tracks were back there, as you can see. So this is a tracked, fully autonomous vehicle that runs a series hybrid powertrain. So basically there's a diesel generator that just recharges the battery, and that battery powers electric motors that drive the tracks.
So far, everything that I've seen here at the Clemson Automotive Research facility has been relatively friendly looking. This is scary.
Yeah, so this was actually part of two projects. It was Deep Orange 13 turned into Deep Orange 14. So it was in partnership with the U.S. Army and the Department of Defense.
Very cool.
So they're developing a tracked autonomous vehicle that could be used for, like, if there was an emergency scenario, could we send this out and maybe, like, say there was a blizzard that shut down a section of the, like, country. We could send this out, we could find out, like, what kind of roads might be usable, or can we carry supplies in on this payload deck here, or even up on top of the vehicle.
Yeah.
So part of the advantage of it being a hybrid vehicle is the large battery pack and the diesel generator. You could actually, like, if there was a hospital that lost power or whatever, you could plug it in and basically run the hospital from this and provide support to that, kind of like its own little microgrid.
Okay, thanks for indulging me on that sick build. Now let's take a look at how they test these vehicles. It's about to get oddly a little quiet. What is this room? This is like it's really quiet in here.
This is one of our dynamometers, so we're testing the vehicle itself, but also it's nice and quiet in here.
Is that for measuring NVH?
Yes, so we're measuring the noise, vibration, and harshness of the vehicles, as well as new things like tire compounds, new types of suspension systems, and similar, so we can get a full appreciation of, as we change and alter the vehicle,
right,
how that affects what it's going to sound and feel like to the vehicle occupant.
Wow. Now, could somebody like Ferrari come in here in like a sound, like dampened room like this and tune their exhaust system?
Exactly.
Because this really is like an audiophile's dream in here, plus a dyno.
Exactly. So we can bring in, test any types of third-party components and parts, how we're going to change and alter, as well as we let our students develop new ways of routing exhaust systems and removing all of the noises that we don't want to hear out of a vehicle.
Gotcha. So how do they dampen? What is this like dampening?
It's
material?
very thick foam and fiberglass insulation. And so we're pulling all of those reflections out so that all we get really is off of the floor here. And so we get some noise off of the floor, but most of it is going to be dampened off by all the walls around us.
Wow. That's crazy. So it's like metal mesh with you said wool and fiberglass? Mm-hmm. Oh, wow. And that's a foot deep. Wow, very cool, man. How many of these do you have?
So we have one engine or one dyno area, but then we have plenty of other dynamometers for testing different types of engines, all the way from small scale single piston engines, which we're looking at the actual dynamics of the piston itself.
Okay.
Where we take it out of that complex situation where we have 4 or more, as well as where we can test full size engines, so internal combustion engines, diesel engines, truck engines. We have many different places that we can test them.
Right, right. Have you guys ever put your cars on here?
I wish.
No.
I wish.
So they're making me regret not driving down.
Yeah.
Should have drove
Put
down
the
instead
rental
of
car on
flying.
there.
Cool, let's see the next room. Man, when I was in college, I would have loved to have these awesome testing labs and toys they have to play with here. From these sound rooms to AI imaging that finds defects in the manufacturing process, and so much more. But what I was really looking forward to seeing was the final assembly process. But first, remember when Matt said at the beginning of the video about,
Even though some of the materials and systems don't exist yet.
well, we were getting to talk with Dr. Lou in her lab to talk about how they make that a reality here. Alrighty. Hi, Dr. Lou. How's it going?
Nice to
Steve,
meet you.
Nice to meet you. Now, this is a lab. Look at this. What do you guys have going on here? You're doing all the manufacturing testing? Is this material? You guys do material science here, right?
So this is moving over into additive manufacturing as well as material science research and our vehicle assembly area.
Okay, very cool.
So
Awesome.
we'll begin with the additive manufacturing work with Dr. Liu.
Yeah, this is my lab for metal additive manufacturing.
Metal additive. Okay. Okay.
Yeah, that's my major research focus. So
Awesome.
I also use additive manufacturing to fabricate new materials.
Okay.
Yeah.
You play with ICME to make new materials? Is that
Yeah, that's the for simulation
Okay,
uses.
yeah.
Yes, for this lab, it's just for experiments. If
Okay.
I work in front of the computer, that's for simulation.
Gotcha. Very cool. All right.
So this big machine is one laser printer.
Okay.
So it has a name called laser powder bed fusion.
Okay.
So
yeah.
it has a powder bed working principle. That means we place the powder in the workbench. So it's like a bed.
Right.
Okay. So this printer was provided by Army Research Lab for
Okay.
a grant. So I'm the co-PI for that grant.
Oh, wow.
Okay. So this printer is a high performance. The laser power is 500 watt. The small size is small, only 80 micron.
Yeah.
So it can control the oxygen level to be lower than 25 ppm. So
Okay.
it's suitable to print some reactive metals like aluminum,
Right.
titanium. So no problem.
So it's got a big build volume?
Yeah, build
Okay.
volume. For example, that build plate, can see this build
Oh,
plate.
wow.
They are just some small samples to show demonstration for some unique features. The surface, this material is super alloy. It's
Okay.
super alloys. So it's used for aerospace mainly.
So is this like Inconel?
Yes.
Okay.
Yeah, you're right. Inconel 718.
718.
Okay.
It's very heavy.
Yeah. build-
The build plate is heavy, sorry for that. So this is some small parts that are fabricated by this printer. And this is the build plate. The build volume, I mean the printed part size, can be a cube like this big.
Okay. So if you're about like this high up, yay high.
Yes. So this printer can print a very complex geometries. So for automotive industry, we can print some engine components.
Oh,
Okay.
okay.
Yeah, using this printer. So
Wow.
it's good for design work. For example, prototyping with
Okay.
some complex geometries. So
Right.
this printer is very suitable.
Awesome.
Yes.
So instead of like tooling up an expensive CNC machine
Yeah.
to cut Inconel, because Inconel's nickel-based, nickel happens to be really easy to print in metal.
Yeah,
Right.
some compensations.
Okay, yeah.
Some compensations.
Gotcha.
Yeah.
Cool. All right, man. This looks like a miniature automotive assembly plant.
It very well is. So this is our Clemson Vehicle Assembly Center. So we're a 1-to-1 scale production simulation environment where we don't just work with Legos or small objects. We deal in the full-size vehicle. So this is actually a vehicle that we brought out of BMW. Where we took the vehicle out of the factory. So we're located right about 20 minutes away from the plant Spartanburg facility where they produce the X3, 5s, and 6. Where we brought the vehicle out, we brought the skid that it was actually sitting on, and we retrofitted it to run on the rails you see below us right here. And that way we can move the process along. We can stop it, break it, do whatever we need to do to make the process changes happen, as well as add things like technology, so new types of robotic systems, assistive systems as well. And we'll see one here. We'll see one here in a couple of minutes.
Awesome. Cool. So should we start back there?
Yes.
Okay.
Let's head on up. So I mentioned that we work in the large scale as well. So we also work with all of the different areas across the vehicle, as well as we don't just deal with the vehicle itself. We also deal with the tools that we commonly use out in industry. So we have a partnership with Atlas Copco, who provides us many types of the cable tools, as well as their newer generations of wireless tools. Because we're teaching our students how to program the tools, but also how to use all of the data and information that's coming off of them nowadays.
That's incredible.
So not just torque and fastening control, but also positional controls, as well as we are looking at how we can combine different information sources together. So we use these small tracking technologies. So this is a ultra wideband tracker that we can use to track different people, objects, and parts throughout the entire facility.
So that's like what we saw on the hood.
Exactly.
Okay.
But now we know where the vehicle is as it's moving through the assembly area, and we also know where the people are that came up and worked on it, who worked on it, what they did, what they attempted to do. And then also what parts were assembled onto that vehicle as well. So now whenever you have a hand scanner, when you take the scan, you also know the exact vehicle and where in their assembly line that it was done.
Incredible.
So you don't care where the work was done, you know what it was associated with.
Gotcha.
So this is one of the exoskeletons that we're studying here in the lab as well. So it's not just about what we bring out and bring to technology from things that they wear, so wearable systems and phones and cell phones, smartwatches and similar, but also how we can apply assistive systems or servo motor based or kinetic based systems that allow us to help and support the associates in the workforce as they're doing these heavy jobs, so that when they come in and when they leave, the only thing that's changed is their age. We don't have any injuries or injuries or permanent lasting damage to them.
Right. So if you reduce fatigue, you can improve safety and overall quality of the work.
Exactly.
Incredible. What the heck, man? Like, first it's Georgia Tech, then it's University of Texas at Austin, and now Clemson. You know, where were these universities when I went to school? You know, I don't get me wrong, I'm glad I studied physics, but I had no idea that there was an entire university that I could have gone to for automotive engineering. But automotive engineering and the automotive industry is only a part of all that manufacturing enables us to do. So thank you to Clemson University. Thank you for their Automotive Research Center. This has been an incredible experience. Have a good one, everybody. See you next episode.